All right, so welcome everyone. I'm happy you made it in this terrible weather. My bus didn't come, so I hope you had a better ride here than I did. My name is Michael Stapelberg. I work on the Go team at Google. I've been co-hosting this meetup for a long time, but Dan is actually doing all of the hard work in terms of organizing the locations. Today, what we have on the agenda is a pretty packed program, and we're already a little bit behind, but no worries, we'll get through all of it. I'm going to start the round with a brief introduction into what's new in Go 123. Then we're going to talk about nil safety, priority channels. We'll have a brief break, a Prometheus exporter, more details on range over function, another brief break, and then GOPS and web UI development. So quite the full agenda. So at this point, I want to thank our sponsors, Smallpdf. Thank you so much for letting us be here. It's always a pleasure. There are a couple of standing offers. If you would like to host this meetup the next time, we're always happy to see new places or visit again one of the graceful hosts we've already had in the past. Please contact Dan. If you want to give a talk, reach out to us so that we can put you on the agenda for next time. And if you're looking to advertise a Go job, just send us a note in advance and we can put your advertisement up here. The next meetup obviously will be in 2025. So happy holidays in advance. And with that, let us switch gears to what's new in Go 123. So 123 was released on August 13th. You might remember that we release Go 2 times a year, once in February and once in August. In fact, just today is the day when the tree has been frozen for the next release. So that means if you haven't followed Go development, the last couple of days, a lot of stuff was pushed in. So you can look through all of the changes and watch us try to stabilize them. The overview I want to give you picks out just a couple of things because there's way too much stuff happening to put it into any sort of reasonable time limit. I will briefly talk to you about range over func, also known as iterators, telemetry, and then lastly, performance in the form of PGO. But before we go there, first of all, how do you upgrade to this release? If you have not actually heard of 123 coming out, maybe you still have a couple of projects. Personally, I find the easiest way to do it is to edit your go.mod file, which contains the language version and optionally also a specific toolchain point release if you really want to be very precise. A convenient way to do it from the command line is to use go mod edit -go to change the Go version. And then whenever you do the next build or test or install or whatever command you have, you will see this message here by the Go toolchain saying, hey, you specified Go 123, but it's not installed. I'm just going to download it for you and run it. And that's what we call toolchain management. Of course, you can also opt out if that is too magical for you, but I personally find it a great convenience and I use it in all of my projects. If you want to learn more, go.dev/blog/toolchain is where you can find more details. All right, so let's talk about range over func. What is this about? The idea behind this whole body of work is to have a standard approach for looping over container types. This is something that other languages have already offered, but in Go it's sort of ad hoc and it wasn't really standardized. So the idea is that you declare functions on your custom types that then return an iterator. So for example, if you have a custom map type implementation, you could have an all function which returns an iterator that goes over all of the keys and values. And in this case, the keys are of type int and the values are of type string. And that's why we're returning a type called seq2, which is a sequence with 2 elements. And these sequence types are defined in the iter package. A simpler example would be if you have a custom file type, and you have a lines accessor, which will return an iterator that is just like a sequence of strings, right? Like line by line. If you have this second example here, the way to use it is just with the regular range keyword. So you could write for_line: range f.lines, and then you just print all of the lines. And it's just a little bit nicer than how you would have to write this before. Of course, the iterators alone are only half of the picture. There's also additions to the standard library and other packages to make working with those more convenient. In general, check out the documentation of the iter package. I've put the link to the Go package site at the bottom. Or as usual, there's a blog post with more details at go.dev/blog/range functions. So what does this look like in practice? Maybe you don't actually have custom map types or want to change how files are split into lines. I get it. But what I find most often very useful is these helpers in the maps and slices packages. So let's imagine that we have like a downloads map. Let's imagine maybe we're doing like a small logs analysis program and we just iterate through all of the downloads and then we keep count of them. So in this case, we see 123 was downloaded 500 times. It's a pretty fresh release. 121 was downloaded the most and 122 was downloaded half of that. These are out of order. As you know, iteration over maps is intentionally randomized. So how do we get them in order? Well, the nice new way of doing it is we call maps.keys, which returns an iterator, and then we have slices.sorted, which takes an iterator, collects all of the elements, sorts them, and then returns them. So the output here would be go 121, 22, 23, right? All of the keys, but in sorted order. Now, if we want to work with the values and figure out which Go version was actually downloaded the most, we could use maps.values, and then there's this slices.max function. But in the middle, we need this other element here, and I'm pointing this out because you need this kind of frequently. The slices.collect is a function that takes an iterator and then just collects all of the elements and returns a slice with it. So you can use this to sort of bridge between an iterator-based API and like a slice API, right? All right, so that's all about range over func. We have a whole presentation later where hopefully we'll see more interesting stuff about it. So let's switch gears to telemetry. Maybe many of you have already followed the discussion, maybe not. So I'm just going to like briefly recap. The idea behind telemetry is that we as the Go developer team would like to collect basic counters like how often does Go please crash, for example, or specific stack counters, like, for example, if we're looking at the X509 package where SHA-1 support was removed from Go a while ago, maybe we would have liked to know how many TLS verifications are like using this still. It's a hypothetical example because telemetry is not actually on like in your production programs, but just so that you get an idea of what sort of stacks are interesting, right? Another example of an interesting stack obviously is any panic that you encounter, and then you're interested, well, how did the compiler get there to this panicking line, right? So telemetry is meant for Go toolchain programs like the Go tool itself, right, including compiler, linker, but also Go please is also part of the toolchain, so to say. Why do I point out that the only thing that telemetry collects is counters? Because that's the whole point of not collecting too much data. Like there should never be any strings, any identifiers, any personally identifiable information, anything like that in telemetry. And how do we ensure this? Well, first of all, we only collect counters, so that limits the potential for abuse. And secondly, every collection needs a public proposal. So even if a program is modified, like let's say some contributor that we haven't properly vetted gets like a backdoor CL into the Go compiler and then declares a new counter that actually leaks personal data somehow, it would still not be collected, right? So the collection happens server side, the definition server side, and you need to go through like the proposal process of Go where you need to have multiple reviewers, etc. It's all in the open, and only then will your stuff be collected. Now, telemetry is opt-in, so nothing leaves your computer unless you tell it to. I would encourage each and every one of you to opt into telemetry, especially if you're using these operating systems that are more niche, like all of the NetBSD fans among you, or stuff like that. Definitely opt in, right? Because we need that signal, right? Then if you want to learn more about telemetry, as usual, go.dev/doc/telemetry. There's also a dashboard that is linked from there, which is public. So if you're interested, you can actually totally look at all of the data that is coming in through telemetry. And it's kind of funny to see because 123 was the first version that includes telemetry. So as the graph goes up, you can sort of see how many people have adopted Go 123, which is also an interesting stat in and of itself. If you're wondering, well, okay, that sounds kind of okay, I guess, but what does it really allow us to do, or what does it provide? How does it work in practice? Just last week, I think, at GoLab, Russ Cox gave a talk called Telemetry Wins. I think the recording is not yet online, but I would encourage you to check it out once it is released. So subscribe to the GoLab YouTube channel for that. And I think there's a couple of really nice examples in there about how this data has helped us improve Go for everyone. Okay, and then lastly, performance improvements. So you've probably already heard me talk about this, but Go has a concept called profile guided optimization, PGO for short. And the idea is that if you take a CPU profile that you obtain from your production service, be it by observing production or by running a load test or some other sort of hypothetical load, you can then take that profile and give it to the Go compiler, which then allows the compiler to make smarter choices about, well, for example, inlining budget, right? It could say, well, this function is probably not worth it to be inline, but then it looks at your profile and realizes, wait a second, your server spends a lot of time in that function, so I'm going to inline it after all, even though without the profile, it wouldn't be eligible for inlining. And this sort of idea results typically in 2 to 14% faster programs. It really depends on the workload, though. The nice bit about this is that PGO was introduced a couple of versions back, and now with every release of Go, it gets just a little bit better. So in this release, for example, we've reduced the compilation overhead with PGO. It used to be much higher. Now you can sort of cache an intermediate step and then bring the compilation cost back down to where it was. And also there's now alignment for hot code blocks inside of loops. So as soon as the compiler realizes from the profile, oh, this loop is hot, it can actually move stuff around a little bit, spread it out maybe, like, use a little bit more bytes, but then get faster code as the result, right? These sorts of trade-offs are what PGO profiles allow you to do. As usual, more information, go.dev/doc/PGO. So at this point, I think you've picked up on the theme. I really want you to read the Go blog, right? So go.dev/doc, and in the page Go 123 is where you can find the release notes and a lot more good stuff. So with that, I'm going to say thank you for your attention. Enjoy the latest release of Go. And now I think we're going to hear about Nilnus. Thank you.